Hello, and welcome to this R3 video demonstration. Today, we'll demonstrate a robot being operated from a remote desktop via Profinet, which is transmitted over a wireless EchoRing network. A standard Profinet EchoRing setup is divided into three key components. To the right, we can see the Siemens S7-1200 Programmable Logic Computer, or PLC. This device wirelessly transmits Profinet data streams over an attached Ethernet bridge. In the center, we can see the robot, which consists of another Ethernet bridge, a teach pendant, the robot's control box, and the robot's chassis. The control box receives two wireless data streams, one from the remote desktop and one from the Siemens PLC. On the left, we can see a remote desktop that transmits data to the robot's control box via an EchoRing Ethernet bridge. This desktop will be used to operate the robot. Here is the entire setup with all of its components at a glance. All components in this setup can be powered either by cable or by battery. Ethernet bridges can also be powered over Ethernet. To begin, the robot's control box is activated by switching on the teach pendant. The PLC and its Ethernet bridge are then activated by switching on the power bar they're plugged into. Integration of EchoRing nodes is protocol independent, which means they can be easily integrated into existing systems. In addition to Profinet, EchoRing can also transmit industrial protocols such as Ethernet IP and PowerLink. This allows for wired applications to be easily retrofitted into wireless. EchoRing networks can be upscaled simply by installing additional wireless nodes, which are most commonly the first-party Ethernet bridge devices shown here. Teach pendants like the one used in this example can also be integrated wirelessly. The robot is now set to operations mode via the remote desktop. The click heard in the background indicates the setting change has been successful. Prioritized data transfer enables an EchoRing network to distinguish between high-priority signals, such as emergency stop commands, and low-priority signals such as network diagnostics. To the right, we can see activity in the Teach Pendant's UI. This is being controlled from the remote desktop. The robot's software is launched and it begins its programmed action. We now head over to the PLC to input the robot's stop command, which is triggered with a physical switch. The stop command is deactivated when the switch is flipped back, whereupon the robot resumes its programmed action. In this next step, we demonstrate how the robot immediately defaults to a safe state whenever its wireless connection is disrupted. We simulate a signal disruption by unplugging the Ethernet cable between the PLC and its Ethernet bridge. The robot instantly goes inert, a function designed to prevent industrial accidents. The Ethernet cable is plugged back in, and there's a brief delay as the PLC reconnects to the network. Back at the remote desktop, we dismiss the robot's connection error alert and manually relaunch the program. EchoRing's decentralized network structure means that all nodes communicate directly with each other, rather than passing through a single vulnerable access point. An isolated signal disruption like the one shown here will not affect the entire application. Features like this allow EchoRing networks to reach the level of reliability required for industrial wireless applications.